Very good morning, class. Welcome to our next lecture of mechanics of material. In this lecture, we are going to discuss the further topics which we have stopped in our previous lecture. So, in previous lecture, we have discussed about deformation of a material, which is based upon stress and strain. So, further, we are going to see stress strain curves. So, what is a stress strain curve? Stress strain curve is nothing but the curves which are drawn by taking stress and strain along x-axis and y-axis. Generally what we do is we take stress axis along y-axis and strain on x-axis. You can observe here. Further, if you want to see, I can zoom it. So in this, the main thing is what generally we do in this is we take a material, and material will be applying a continuous stress. So when you are applying a stress, obviously because of stress there will be a small deformation produced. So if initial case, as per the Hooke's law or as per the Hooke's, most of the time in many ductile materials, it generally happens that so when you apply the stress, there will be a strain generated. So till some extent, the stress and the strain will be directly proportional to one another. That we have already seen in Hooke's law. Hooke's law states that stress is directly proportional to strain. So this point A is nothing but called as your proportionality limit. Why means till here the material will be purely proportional with respect to stress and strain. If you give a stress initially, if stress is 0, there will be 0 strain. If you are giving 1 units of stress, with respect to that there will be generation of strain about 0.01. So similarly, if you increase the stress, same amount will be increased in this. So that will be equally proportional to one another. With the ratio will be always equal. The ratio will be always equal with respect to stress and strain up to a limit, that is A. So that limit is called as proportionality limit. Again, after the proportionality limit, if you still increase the stress, so there will be a point where the material will be like elastic. So whole along this whole range, the material will be elastic itself. Even after proportionality limit, there will be a point where even though the stress and strain are not proportional to one another, but it will be again elastic only. So what does this elastic means is nothing but during this O to A, for example, if I consider this as origin, for example, if I consider this origin and this is my point A, if I remove the stress here, the object will come back to its original position along this same path, okay. If for example, if I remove this, it will come back in the same path. Next, even after crossing this limit, after crossing this point, it will be again elastic itself, but whereas it is not a straight line, it is having some curvature. This point is called as elastic limit. If you again cross this, if you apply the stress beyond this B point till some extent, that point is called as C, which is nothing but yield point. What does this yield point is nothing but after this yield point, the material will enter into a plastic region. After this melting point, this is enters into a plastic region. Generally, we have two yield points, upper yield point and lower yield point. For mild steel, it is like this only. So this point is called as yield point. Generally, if I want to explain a yield point, the point where the material will undergo plastic deformation starts. Okay. Again, if you keep on applying the stress beyond the yield point, it will be keep on increasing like this. The strain will be keep on increasing and stress is also increasing. After a certain point, it will reach to a maximum point. The material can withstand that maximum point. That is nothing but ultimate tensile point. Ultimate tensile point. After this, even if you don't increase the stress, after this, even though you don't increase the stress, there will be still increase in the strain. There will be still increase in the strain. So you can observe this. You are not trying to increase the stress, even then the strain is increasing, and it will reach a point where the material will break into pieces. That is nothing but a breaking point. Okay. Here the material will break into two parts. If it is a ductile material, it will be break into cup and cone shape. It will break into cup and cone shape. Similarly, if you see for a brittle material, there will not be any plastic deformation. What is an example of brittle material? Your glass. Okay, your stainless steel. So these are the brittle materials which does not undergo any kind of plastic deformation. In this till B point everything will be same. There will be proportionality limit, there will be elastic limit. After that, if you try to increase, there will not be any yield point, means that will not undergo any plastic deformation. Here it will directly go into breaking point. If you observe in this diagram, previous diagram, this region is nothing but plastic region. If you in this region, if you try to remove the stress, the strain will not follow the same path. The strain will not follow the same path, but whereas in elastic region it will follow form the same path. And this area which you are observing under this is called as strain energy, which we will seeing in the further classes. Okay, that area is under the elastic region is called as strain curve. Okay, so for example, see this, we are having a problem here based upon this. Sorry for the inconvenience. See this problem. So the following observations were made. Try to note this please. The following observations were made using the tensile test on a mild steel specimen, 40 mm diameter, 20 mm long, elongation with 40 kilonewton load within elastic limit. So this load is within elastic limit. When I am applying this load, I am getting a deformation of 0.0304 mm. They have given the elongation. Elongation is nothing but deformation, extension you can say anyway. Next, they are giving the yield load. After elastic load, they are still applying the yield load of 161 kilonewton. Then they are applying a maximum load of 242 kilonewton. When they are applying 242 kilonewton length, the length of the specimen has been extended to 249 mm. 249 mm. Determine Young's modulus, yield stress, ultimate tensile stress, and percentage elongation. Okay, they have asked this. So let us take this problem. What are the given data? First we have to note down. First they have given the diameter 40 mm. As I have previously told you, most of the problems the dimensions of linear dimensions like then the diameter will always be given in mm. So try to solve the problem always in mm in this case, in most of the MOM cases. So diameter is 40 mm, long is 200 mm, load is 40 kilonewton within the elastic limit. Kilo they have given, so we'll convert into 40 into 10 to the power of 3. Elongation they have given delta L, that is 0.0304 mm. Yield load they have given 161 kilonewton. Kilo they have given, so we'll convert to 10 to the power of 3. Maximum load 242 kilonewton, that is why kilo is converted to 10 to the power of 3 newtons. Now the length of specimen fracture they have given us 249 millimeter. First question they have asked is Young's modulus. So we know that Young's modulus, stress is equal to E into strain, that is stress by strain is equal to Young's modulus, that is stress is equal to E strain. E is nothing but your Young's modulus here. Okay, so I know what is stress. Stress is nothing but load upon area, P by A, whereas strain is nothing but delta L by L. Strain is nothing but delta L by L. Now E is equal to what will happen, PL by A delta L. PL by A delta. Do cross multiplication here, L goes here, delta L comes down. That is why PL by A delta L, where the value of P is 14 to 10 to the power of 3. L value we have known it to be 200, and area is always for a circular, when diameter is given, area is pi by 4 d square. The d is 40 square into delta L is 0.304. So try to solve this by using a calculator. You are going to obtain the value like this, 209,414.398. So which is almost equivalent to, here the point is here, so I am taking 5 points, 1 2 3 4 5. So I am raising the power by 5, 2.09 into 10 to the power of 5 Newton per mm square. Why here mm is all the dimensions you see here, these are also mm, these are also mm. Okay, so for that reason you try to keep it in mms. Next is yield stress. When I say yield stress, what do you know? What we know about stress is nothing but load upon area. When they say yield stress, you have to take yield load upon area. So yield load they have given you 161 into 10 to the power of 3. Now area they have given by using diameter, we can find pi by 4 40 square. 40 is your diameter. So with that you are going to obtain it to be 1.28 into 10 to the power of 2 Newton per mm square. Try to solve this, you will find the value as 1.2 into 10 to the power of 2 Newton per mm square. Similarly, they have asked for ultimate tensile strength. Ultimate means maximum tensile strength. Whereas for finding maximum tensile strength, they have given you maximum load. They have given you maximum load. Now ultimate tensile strength is equal to maximum load by area. Maximum load is nothing but 242 into 10 to the power of 3 divided by pi by 4 into 40 square. With that you can find it to be 1.92 into 10 to the power of 2 Newton per mm square. 1.92 into 10 to the power of 2 Newton per mm square. Next is percentage elongation. They have asked you percentage elongation. See this question. For fourth question, they have asked you percentage elongation. Fourth, they have asked percentage elongation. So we are trying to find percentage elongation. So what is percentage elongation? If you see here, sorry for the inconvenience. See this, the percentage elongation here is final length minus initial length by original length into 100. Why? Why 100? Because they have asked percentage elongation. Elongation generally we know final length minus initial length by original. At the time of breaking, the final length is 249, which is given in your problem. 249 minus 200 by 200 into 100. Final length minus original length by original length into 100. That is 49 by 200 into 100, which you are going to obtain as 24.5 percentage. Okay, I hope everyone is clear with this. Note down this. If you have any doubts, please ask in comment section or WhatsApp. Okay, next question. A hollow cylinder of 2 meters long has an outside diameter of 50 mm and inside diameter of 30 mm. If the cylinder is carrying a load of 25 kilonewtons, find the stress in the cylinder. Also find the deformation of cylinder. If Young's modulus of elasticity for the cylinder is 100 gigapascals, they have given Young's modulus elasticity is 100 gigapascals. So let us see how to take the given data first. So the given diameter is, first they have given outside diameter. We write it as DOR OD. DOR OD. Or outer diameter is equal to 50 mm. Inside diameter ID is equal to 30 mm. The load is P is equal to 25 kilonewtons. Since it is kilo, we'll write it as 25 to 10 to the power of 3 newtons. So next is Young's modulus. E is equal to 100 gigapascals. 100 into giga means 10 to the power of 9. I've already given these values: giga, mega, kilo. Kilo means 10 to the power of 3. Mega means 10 to the power of 6. Giga means 10 to the power of 9. Pascal. Pascal means Newton per meter square. Remember this, Pascal is nothing but Newton per meter square. So since the units are in mm, have to change this meter square into mm square. So 1 meter is equal to 1000. When I multiply meter into meter, it will become 2 times. That is 10 to the power of 3 into 10 to the power of 3, it will become 10 to the power of 6 millimeter square. So this 10 to the power of 6 is in the downward, this is 10 to the power of 9 is in the upward. So if you solve these two, then you will be obtaining 100 into 10 to the power of 3 Newton per mm square. Now the length they have given as 2 meters. So since this is in meters, 1 meter is equal to 1000 mm. So 1000 into 2, it will become 2000 mm. I hope it is clear for you till here. Next is what they have asked, we have to solve this. Now first of all, let us find the area of the hollow cylinder. We know that area of hollow cylinder will be AH is equal to pi by 4 of d outer diameter square minus d inner diameter square. D outer diameter square minus d inner diameter square. That is pi by 4 of 50 square minus 30 square. You are going to obtain this value 1256.64 millimeter square. Try to solve this in your calculators. Calculators are must when you are trying to solve these kind of problems. Next, from this you have to find the stress. What is stress? Load upon area. Stress is load upon area. What is the load they have given? 25 kilonewtons. So I am taking 25 into 10 to the power of 3 divided by 1256.64, which you are going to obtain as 19.89 Newton per mm square. 19.89 Newton per mm square. Now find the deformation. So what is deformation? We have already noted this formula in the second lecture, that is delta L is equal to PL by A. Delta L is equal to PL by A. Now P by A is nothing but sigma. So we can write sigma L by A. Now you know the value of sigma already here. Sigma value is already known here. You can directly use the value of sigma. 19.89 into what is your length you have taken is 2000. 2000 divided by what is your E, they have given as 100 gigapascals, which you have converted as 100 into 10 to the power of 3 Newton per mm square. Now if you solve this, you are going to obtain it as 0.3978 mm. Once you solve this whole problem, you have to note down what they have asked, what are the things they have asked. You can make a separate note of that. That is, they have asked as stress, so we are writing stress separately here. They have asked as deformation, so we are writing the deformation separately. You can make a note of all these things at a separate section, and you can show that this is the answer we are going to obtain. Next problem. Let us see the next problem. I hope everyone is clear with this problem. If you want to see go through it again, you can go through it once again. So area is equal to pi by 4 d naught square minus di square, because this is a hollow section. If it is a complete solid section, we have to take pi by 4 d square itself. But whereas since this is a hollow section, how the hollow section is visualized, we can be, it is observed like this. If you see this, so this is the outer diameter, this is the inner diameter. It is like a pipe. So one whole section is there which we have cut from inside. This is a hollow section, this is having a material. This, in this way they have given you this problem. So that is why, since the material inner diameter is removed, we have to make it minus pi by 4 of d outer minus d inner square. So we will find the value of the area here. Once you find the area, you can able to find the stress, because load is given. Once the load is given, you can able to find the value of stress. Once you find the stress, you can find the value of deformation. So that is sigma L by E. You can use this formula when load is given and area is known, or you can directly use this formula if they don't ask, if they have directly given you stress. You can use any formula basing upon the type of problem. Okay, so you are going to find the deformation as delta L is equal to 0.3978 mm. Okay, let us see the next problem. The two wires, one of steel and another of copper, are of same length. The lengths of the both the materials are same, and they are subjected to same tension. Tension is nothing but a pulling load. So pulling load is nothing but, that is, pulling force is same on both the sections, that is either steel wire or a copper wire. If the diameter of the copper wire is 2 mm, now they have given the value of copper wire which is 2 mm. Find the diameter of steel wire if they are elongated by same amount. If they means what? Both the wires are elongated by same amount. Take E for steel as 200 gigapascals, whereas copper as 100 gigapascals. So first let us take down the given data. The length of the steel is, that is LS, we are indicating as LS because length is L, is nothing but steel, is equal to length of copper, where they have given one of the steel and copper wire of same length they have given, so we are making it equal here. Next, load as tension in steel, PS is equal to load of copper, PC is equal to PS. It is nothing but both the loads are equal. Next, the diameter of the copper, is nothing but 2 mm. Diameter of steel is, we don't know, which we have to find. Next, elongation of the copper wire is equal to elongation of steel, that is delta L of C is equal to delta L of S. Now they have given the Young's modulus or modulus of elasticity, ES is equal to 200 into 10 to the power of 9 Newton per meter square, which I can convert in and write it as 200 into 10 to the power of 6 Newton per mm square. I have already shown this. 1 meter square is equal to 10 to the power of 6 mm square. 10 to the power of 9, 10 to the power of 6, which will get cancelled and it will become 10 to the power of 3. Similarly here, EC is equal to 100 into 10 to the power of 3 Newton per mm square. Now, since they have given delta L of copper is equal to delta L of steel, we will make them equal since they have given. Now, first of all, write the formula for delta L. What is the formula for delta L? PL upon AE. If it is asked for copper, we will write PCLC by ACEC, where PC is nothing but load applied on copper, L is nothing but the length of copper, A is area of cross section of copper, E is Young's modulus of copper. Similarly for steel, length of load of steel, length of steel, area of steel, Young's modulus of steel. Now since they are equal, we can equate these two values. We can equate these two values. PC LC by AC EC is equal to PS LS by AS ES. But they have given PS and PC are equal, so we can cancel them. And LC and LS are equal, so we can cancel them. So what is left out is 1 by AC EC is equal to 1 by AS ES. So don't get confused here. Since both are equal, we can able to cancel them. Since we have cancelled, one will be left. PS 1s are PS 1s are. So 1 is left here. 1 by AC EC is equal to 1 by AS ES. Now we do cross multiplication. So AS ES is equal to AC EC. AS ES is equal to AC EC. AS ES is equal to AC EC. Now what is area? If they have given the diameter, what we will write? Pi by 4 d square. But whereas since this is for steel, we will write ds square. And they have given the value of ES, we will write the value 200 into 10 to the power of 3. That is equal to area of copper pi by 4 into dc square into 100 into 10 to the power of 300 into 10 to the power of 3. Since the value is given, this 10 to the power of 3, 10 to the power of 3 will get cancelled. Again 100 ones are 100 twos are. Pi by 4 will get cancelled. What is left out here? ds square into 2 is left out, and here everything is cancelled. Only left out is your dc square. Only left out is your dc square. So ds square into 2 is equal to dc square. ds square into 2 is equal to dc square. I want the value of ds because dc value they have given. So I will send this to multiplication of 2 on other side. Since it crosses the equal to, since it is transformed from this side to other side, it will become division. Since this is a multiplication here, when it goes on the other side, it will become division. So ds square by dc square by 2. But whereas we know what is the value of dc which they have given us, that is 2. ds square is equal to 2 square by 2. 2 square value is 4. 4 upon 2 is 2. Therefore, ds square is equal to 2, which is ds is equal to under root of 2, because I want the value of ds alone. I don't want the value of ds square. So I am removing the square. How we can remove the square is by applying the square root. So I am applying the square root. I am going to obtain root 2. So because of that, ds value is, what is the value of root 2 is 1.414. If you don't know the value of root 2, you can directly type it in your calculator. You can find the value of root 2, which is like ds is equal to 1.414 mm. That is, the diameter of steel wire will be equal to 1.414. Diameter of copper was like 2 mm. Now it is like 1.414 mm. Okay, with this we can end. Please note down this question. This question is for homework, so you have to submit this on WhatsApp and for my personal number. Okay, so please note down this question. I will give you 2 minutes. I will read out the question so that you can have a clear picture of this. A hollow steel tube. Whenever they ask hollow, you have to take the area as pi by 4 d outside diameter minus d inside diameter. They have given the external diameter. They have given length here. We will follow the question. A hollow steel tube of 3.5 meter long, length is given, has external diameter of 120 mm, and they have told in order to determine the internal diameter. What do you have to identify now? Internal diameter. We don't know the internal diameter. D inner we don't know. The tube was subjected to a load. Load means P they have given 400 kilonewton. Whenever you see kilonewton, what you have to do? You have to multiply with 10 to the power of 3. That is, and the tube got extended to 2 meter length. Extended is nothing but extension or deformation. So this is nothing but your delta L. How much is the delta L? 2 mm delta L is happening. If modulus of elasticity for the material is 200 gigapascals. 200, what is giga here? 10 to the power of 9. See here, area when you are going to find pi by 4 d outer diameter minus t inner diameter. Inner diameter you don't know. But whereas you know the value of delta L. You know the formula for delta L. Delta L is equal to PL by AE. Just now I have written the formula here. You can see the formula. Delta L is equal to PL by AE. P is given, length is given, E is given, and delta L also given. A is not known. A is not known. So this is 2 mm. This load they have given it as 25 or 40 something. So with that 400 they have given, 400 you will substitute in the place of load. In the place of L you will substitute 3.5 meter is given, you have to convert into mm, that is 3500 mm. By area you will write as it is, A keep as it is, then E they have given as 200 gigapascal. Try to solve this. I will give the answer of this in the next class once everyone solve, and if there are any doubts with basing on that I will try to solve this. Okay, with this we can stop this lecture. Thank you.